Okay, so for the first one, we have negative 3 is less than 4x minus 3 is less than or equal to 9. Okay, so notice we need to solve for x here. So how would you get x by itself? Just look at the middle part. What would you do, Anu?
You would add 3.
Okay, so you have to add 3 because we're still trying to solve for x. So if I add 3 here, and this is what I've seen happen with a few of you, is you want to add 3 to the 9, but then you also want to add 3 over here, okay? Because it's a compound inequality. So compound inequalities have 2 answers. All of these types of inequalities that you're doing tomorrow are going to have 2 answers. Okay, so we added 3. This becomes 0, which is still considered a number, so we write it. 4x is in the middle. And, whoops, and 12 is over here. Yes.
Oh, this is there.
Oh, thanks. Oh, that's not mine. Yeah, that's fine. I'll return it. Okay, and then we need to still get x by itself, so what do we need to do? Emmanuel?
You need to divide 4 by.
Divide everything by 4. Okay, so again, we divide the 12 by 4. We divide the 0 by 4. Okay, 0 divided by 4 is 0. X goes in the middle. And notice also, okay, I know this is not the case here, but if you were dividing by a negative 4, that would have flipped both symbols. Okay, so that still applies. Dividing and multiplying by a negative and flipping the symbols. But this is not flipped. So this would be my answer. Now, if I were to graph this, is this an and or an or?
It's an and.
It's an and, okay? It doesn't have an and in the middle of it, but it is put together with the 2 inequality symbols and the variable in the middle, and that is how the and inequalities are set up. So we know it's an and that should give me a clue about what my graph should look like on my number line. All and inequalities are facing towards each other. The arrows point towards each other. So I'm going to graph these together on the same graph. But the lines are going to go towards each other. So we put an open circle. Why is it an open circle at 0?
Because the first one is.
Okay, so there's no line underneath. Yep. And that says if we read from the variable, this is the most important part of these inequalities, guys, because a lot of you do not still do that. Read from the variable. X is, it's open towards x, so x is greater than 0. That means the arrow needs to point greater than 0. Then we have a closed circle at 3 because the line's underneath. And this reads x is less than or equal to 3. So that's less than to the left. So the arrows are going to go towards each other. Okay? So that would be your number line. And this would be your answer. Okay? Questions on this one? Yeah.
I mean, I got it right, but. Oh yeah. What if you mess up? How are you supposed to know which way the arrows go on the number line each time?
You read from the variable. So wherever you're reading from, okay, if it's pointing towards the variable, that's a less than. If it's open towards the variable, it's a greater than. That's how I remember every time. But you have to read from the variable. That's very important. That would be the best way to tell which way to go. Okay. The other clue, though, is that it's an and inequalities always go towards each other. So that should give you another check.
The thing I messed up on is remembering what sign is less than and what sign is greater than.
Yeah. Pointing, okay, less than. Open, wherever it is, greater than. Okay. Wherever you're reading from, that's how I remember. All right. Next one is number 2. Number 2, we have which value of x is not a solution to to 2x minus 1 is less than 3, or 5 minus x is less than or equal to 1. Okay, so for this one I would suggest just solving them first, okay, and then you could figure out which one doesn't apply. So if we're going to solve these, we just solve them separately, okay, so or inequalities, you just solve each one separately. So we're going to add the 1 on both sides here. We have 2x is less than 4, and then we're dividing by 2. Now we didn't flip any symbols or anything, so that's one of our answers. X is less than 2. Since it's an or, we put an or in between the answers, and then we want to solve this one. How would we solve this one? This one's a little tricky to solve. Anu?
5 minus x is greater than or equal to -1.
Oh, no. You only do that with absolute value inequalities. So this is just
my
set
bad.
up how it is. So we just solve this how it is.
You would
So-
subtract the
Subtract the 5. That's what's tricky, okay? It's subtracting 5 because it's positive 5. Okay, so we subtract the 5. Now this is also tricky. Negative x needs to be brought down. Okay, less than or equal to negative 4. Then what? Katrina?
You divide.
Divide. Yeah, this is a negative 1. So, again, I said this in the beginning. You're dividing by a negative. That's always going to apply from now on. So we flip the symbol. This actually becomes positive 4. It's very important that you do this because that's going to affect your answer choices. So what we need to do now is we need to test out each answer. Okay, and if it matches one of these criteria, then it's going to not be our answer because they want not a solution. Okay, so x is less than 2. Is 0 less than 2? No?
Yeah, it is.
Yes, 0 is less than 2. So that crosses it off. We don't have that because it's saying which is not a solution. Okay, so 0 is 1. Now, is 2 less than 2?
Not equal.
No.
No, it's equal to 2. So 2 is a possibility. Okay, then we're going to check 4. Is 4 greater than or equal to 4?
Yes.
Okay, it's not less than 2, but it can be greater than or equal to 4 because it's an or. So it matches this one, so that one gets crossed out. Okay, and then 5, is 5 greater than or equal to 4? Okay, it's not less than 2, but it can be this. Yes, right? So that crosses that out. So the only one that is not the criteria is 2. Okay, so 2 would have to be your answer there. And that's what I would suggest tomorrow for the quiz, is just solve them both and then see which one doesn't match, okay, isn't an answer. All right, number 3.
Oh, this one I have.
Now this is absolute value. This is where you have to do flipping of the symbol and negatives, like Anu was saying. So you have x minus 3 over 4. When you see these symbols here, that means I need to solve it and have 2 answers, okay? So, the first one I solve is just like this, okay? First thing though is, what kind of answer is this going to be? Is it going to be an and answer or an or answer? An and, because of the less than symbol. So less than is what I've been saying this whole time. So we know our answer is going to have to go together. Now, something I might not have said in the beginning that might help you is if it's an and problem, in the very beginning, you can go ahead and put on the other side the same symbol but a negative. And that means x is greater than or equal to negative 3, which is what you're going to have to do anyway. So now you have it all set up and you just solve. So if that helps you, that's fine. Or you could have done x minus 3 over 4 is less than or equal to 3. X minus 3 over 4 is greater than or equal to negative 3. And then put it together at the end. Either way is fine. Which one would you like to go over? Which one have you been doing? Probably this way
Yeah,
more?
that one.
Okay, so let's say we did this way. If that helps, though, you can do the other way. All right, this way, we're going to solve this one just like it is, okay? But when we start solving, I said this before, you take away the absolute value symbols, okay? And what our answer is going to be is this one and this one put together, okay? So we have x minus 3 over 4 is less than or equal to 3. X minus 3 over 4 is greater than or equal to negative 3. We're going to solve both. How would you solve? Lydia? Multiply by 4, okay? Because you want to get rid of the 4 first. So we're multiplying by 4, and that cancels out the 4. Then we have x minus 3. Still have less than or equal to 12. And then add 3. So x would be less than or equal to 15. Now we go over here, and we solve the other one. We still do the same solving process. Multiply by 4 and multiply by 4. But we have x minus 3 is greater than or equal to negative 12. So then we add the 3 to that. So x would be greater than or equal to negative 9. Now, this is an and problem, okay? This is a little tricky, but put your variable in the middle, okay? One of them is going to be exactly written as it is. So let's say this one is the exact same. The other one, if you're reading from the variable, this says less than or equal to. So I point it towards the variable, and I put the 15 there. And that would be how you put it together. That's if it's an and. If it's an or, you just leave it separate, and you put or.
So for the second one, you change the sign?
You change the sign and the symbol. That's for all absolute value inequalities, whether it's an and or an or. You still change the symbol and the sign. Okay? But notice that I did not, because some of you did this, notice that I did not change anything in the absolute value part. I only changed the symbol and the sign here and here. Okay? And then to graph it, we talked about graphing an and. Okay, we know that it's going to go towards each other. We have 15 and negative 9. Okay, I think I went by 3's on here. So negative 9, negative 6, 3, 0, 3, 6, 9, round room 12, 15. Okay, but on your graph, you're going to have 2 closed circles because of the equal to. So negative 9 closed circle, 15 closed circle. And then we already know it's an and, so you don't even have to think about which direction they go. They go towards each other. Okay, but again, if you read from the variable, it would tell you that x is greater than or equal to negative 9, which goes to the right. X is less than or equal to 15, which goes to the left. So they go towards each other anyway. Questions on that one? Good. Next one is also the same process, okay? But notice that the next one is a greater than symbol. So that one's going to be